Okay guys, I'm going to try to record this video real quick before people start walking in. So I started off with the definition from Wikipedia, and I know that's not a very reliable source, but it's good. It really is. It's actually it's a good starting spot for a lot of things. So it starts off and it says, in mathematics, a logarithm is the inverse operation to exponentiation. We already know that the log undoes an exponential, or an exponential would undo a log. They're inverse operations. But here's the important part that I wanted to get at. That means the logarithm of a number is the exponent. So right there, first of all, let's just pause. And if you don't understand what I just said, slow down and listen. A logarithm is an exponent. It is an exponent. So, well, let's keep going. It says, to which another fixed value, the base, must be raised to produce the number that you're taking the log of. So if I have like log base 2 of 16.5, the logarithm is an exponent. So it's pretty much saying, let's see, is the exponent to which another fixed value, the base, so to which 2 must be raised to produce that number, 16.5. So the logarithm is spitting out the value that I have to raise 2 to get 16.5. Its answer is an exponent. Okay, so remember I talked about how to convert from a log to an exponent. If this equals some value, you switch these two, and that becomes the base of your exponential. So you have 2 to the x power equals 16.5. 2 to the x power equals 16.5. So what a log is actually spitting out and answering is, what power do I need to raise 2 to get 16.5? Okay, that's what a log is doing. It's actually, a logarithm is, again, it is an exponent. Okay, so with that being said, I opened the book real quick, and I'm going to write down and review some of these rules of exponents, because a logarithm is an exponent, and the rules of logs are pretty much the exact same thing as rules of exponents. You just have to remember a log is an exponent. So, exponential rules. A to the m times a to the n would equal a to the m plus n. So remember, when you are multiplying exponents together and you have the same base like this, then it's the same as adding the exponents. Okay? So that's going to be a logarithmic rule in a second. So I'm going over these for a reason. Another one would be if you have, well, I'm going to skip this one. I think it goes better in order this way. So if I have a times b to the m power, that's the same as a to the m times b to the m. Like that. Here's the one that I wanted to kind of put third. So this is like same base, different exponents. This is different base, same exponent. Now there's a totally separate thing where you have like a power to a power. So for example, if I have a to the m, and then that's raised to the nth power, that's the same as doing a to the m times n, as far as my powers are concerned. Okay, or a to the m, you don't need to necessarily put the dot. A to the m n, something like that. So if I have a power to a power, or an exponent raised to another exponential power, that's the same as multiplying my exponents together. And then subtraction and division are linked as well. So if I have like a to the m divided by a to the n, that's the same as a to the m minus n. So if I have two exponents being subtracted, now remember, a log is an exponent. So if I have two exponents being subtracted, or divided, that's the same as subtracting the exponents. Or maybe separate bases. So if I have a over b to the m, right, then that's the same as a to the m over b to the m. Okay, so I just wrote all those back up here because y'all at one point were very familiar with these rules. Okay, so if you're looking at all of these, all right, the rules of logarithms are very similar because remember, a logarithm of a number is an exponent. It's the exponent to which another fixed value, the base, must be raised to produce the number that you're taking the log of. Okay, so with that being said, let's look at the book on page 380, and let's look at these logarithmic rules. So right here it says the log, I'm going to make sure that you guys can see that on the video. Not very well. Decently though. Okay, so what this is saying right here, this first one, I'll just write it right here. It says log base b of mn equals, so remember if you're doing exponents, then you're saying the log of this exponent, or the log base b of m is an exponent, and the log base b of n is another exponent. So you're multiplying exponents. And we know based on those exponential rules a second ago that that's the same as adding the exponents. So when you're multiplying exponents, you can just add them together. Okay? When you're dividing exponents, so like log base b of m divided by n. When you're dividing exponents like that, and that's what this one says right here, that's the same as subtracting them. Log base b of m minus log base b of n. That's the same as subtracting them. And then when you have an exponent to an exponential power, so when you have log base b of m, and then, so that's an exponent in and of itself. That is an exponent by the definition of logarithms. And then you raise it to a power, like the nth power, then that's the same as multiplying those two things together. So you do, that's the same as taking the n and kind of putting it out here in the front and multiplying it by that whole thing. So what would that look like? That would look like this. N times log base b of m. So notice I do n and then I multiply it by this exponent. So you got to keep in mind this whole thing right here is an exponent. So that's an exponent to an exponential power. And that's the same as multiplying my exponent by the power that it was raised to. Okay? And these are all rules that I just wrote down with exponentials. So if you didn't understand that, go back, look at the exponentials, and listen to what I'm saying there. And you'll see that these logarithm rules are the same as the exponential rules. You just have to get in your mind, and it's kind of difficult to get used to, that log base b of m, that is an exponent. Okay? It's the exponent specifically to which I have to raise b to get m. Okay? By the definition of what a log is. Okay. So with that being said, let's go through some of these problems real quick. I think I'm going to work through a lot of the odds, and I'm going to do it very quickly. Okay, just because I don't want to make a super long video. So anyway, it says, in exercises 3 through 8, use log base 7 of 4 is approximately 0.712, and log base 7 of 12 is approximately 1.277 to evaluate the logarithm. So this actually confused me a little bit. I hadn't seen problems quite like these ever before, but they're easy to understand once you see what they're trying to get at. It says, okay, use those, use this and this to evaluate what log base 7 of 3 is. Well, you got to realize log base 7 of 3 is simply 12 divided by 4. So log base 7 of 3 is log base 7 of 12 divided by 4. Okay, so that's the first thing they want you to recognize. And they want you to recognize, well, log base 7 of 12 divided by 4 is the same thing as log base 7 of 12 minus log base 7 of 4. Remember, I'm dividing two exponents, so I can subtract them from each other, like that. Well, I know log base 7 of 12 is approximately 1.277, and log base 7 of 4 is approximately 0.712. And when I subtract them from each other, let me make sure you guys can see that on the video. Yeah, decently enough as I talk through it, so it should be good. So if I subtract these from each other, I get, I think it's like 5.565. So that would mean log base 7 of 3 is 0.565. I might be off just by a little bit because I'm going based on memory. I actually worked all these problems over here, so maybe I'll just hold this in front of me as I do these. Okay, so next one. Log base 7 of 16. Log base 7 of 16. I actually did this one next, but I decided I'm going to go through the odds. So I'm not going to know the answer of this one either, but I'll show you how to do it. Log base 7 of 16 is it's the same thing as log base 7. Now I need to put it in terms of things that I know. 16 is 4 times 4. Okay, so I'm multiplying two exponents together, and that's the same as adding them. So that's the same as log base 7 of 4 plus log base 7 of 4. So realize I'm using those exponential rules that we were talking about just a second ago. Log base 7 of 4 is approximately 0.712. So I'm doing 0.712 plus 0.712, which should be 1.424. 1.424. Okay, on to the next one. Number 7. Log base 7 of, and hopefully you guys are catching on to what I'm doing now. So if I have a division here, that's the same thing as log base 7 of 1 minus log base 7 of 4. So I'm just using these laws of logarithms, but really it's just the same thing as log of exponentials. So log base 7 of 1, we know that anything to the 0 power is 1. So I know that log base 7 of 1 is just 0. So they're testing one of your identities pretty much. And then subtracting log base 7 of 4. Log base 7 of 4 is 0.712. So minus 0.712, that's going to equal negative 0.712. So number 7 answer is negative 0.712. Okay, on to the next section. Now hopefully all these I've got worked out on this paper here. So it says match the expression with the logarithm that has the same value. Justify your answer. Okay, so log base 3 of 6 minus log base 3 of 2, pretty much they write justify your answer because they don't want you just typing this in and then typing all of those in and seeing which one gives you the same decimal point or the same numeric value. So that would be kind of like a cheating way. Maybe a good strategy on a test, but not as far as understanding this stuff is concerned. They want you to take this and they want you to form one log with it. So if I'm subtracting log base 3 of 6 and log base 3 of 2, that's the same thing as log base 3 of 6 divided by 2. If I'm subtracting them, that's the same as dividing. Okay, so 6 divided by 2 is 3. So log base 3 of 3. So number 9 links with B. And then I'm going to go ahead and skip 10 and go to 11. So remember, there's this rule where if you have an exponent, you can take it and place it in the front because raising an exponent in log base 3 of 2, real quick, log base 3 of 2 is an exponent. And raising an exponent to an exponent is the same as multiplying them. Okay, so really what they want you to realize is the reverse order. So instead of multiplying, let's bring it back over here. So this is the same thing as log base 3 of 2 to the 6th power. And 2 to the 6th power, I know 2 to the 5th power is 32. So times 2, again, that's 64. So that should equal log base 3 of 64. So A goes with 11. Okay, I'm going to keep going now. So number 13. It says expand the logarithmic expression. Okay, so now instead of condensing, which we were doing a lot here, we're going to expand it. So we have one kind of solid logarithmic expression here. Log base 3 of 4 times x. So remember, if you're multiplying exponents, and remember a log is an exponent, that's the same as adding them. So this is just log base 3 of 4 plus log base 3 of x. And that should be it fully expanded. Okay, now something that's tricky about this next one is that this x to the 5th power is only on, the 5th power is only on the x. It's not also on the 10. For example, if it were on both, it would be written like this. It would be written like log of 10x to the 5th if it were on both. But it's not written like that. It's only on the x. So the way you would rewrite this is first realizing that you have 10 times x to the 5th. You have log of 10 plus log of x to the 5th. Next thing you want to realize is that this is an exponent right here. This is an exponent to an exponent. So it's a power to a power, which means I can, instead of writing it like that, instead of writing it like log of x to the fifth, I can take this 5 and put it right out in front like that. So what I have now is log of 10 plus 5 log of x, like that. Now keep in mind, every logarithm that doesn't have a base actually there is by default base 10. So this is log base 10 of 10, log base 10 of x. So log base 10 of 10 is just 1. Okay, so my final answer is actually just 1 because this right here cancels. It's just 1 plus 5 log base 10 if I wanted to put the base 10 of x. That'd be my final answer there. Number 17, it says natural log. So remember, natural log is just log base e. That's what natural log is. Of x divided by 3y. Okay, so I have x and I'm dividing by 3 and I'm dividing by y. So remember, when you divide exponents, remember log base e of x is an exponent, log base e of 1 over 3, log base e of 1 over y, those are all exponents. So when you divide by an exponent, you're subtracting the exponent. So you have pretty much log base e of x. And I don't mean to confuse people, but I want you to understand that log base e is the same thing as natural log. So minus, because I'm dividing by 3 and I'm dividing by y, log base e, which is just natural log of 3, minus, I'm also dividing by a y. Again, I don't want people to be confused by that, so I'll say it one more time. That natural log is the same thing as that log base e. They're the exact same thing, written two different ways. In the same way that 1/2 is the same thing as 50%. Okay? Those are the exact same thing, written two different ways. Okay? In the same way, these are the exact same. All right. Minus natural log, or let me write it one more time this way. Log base e of y. Okay? So that would be written totally out. And that would be done. So 3 parts to that one. This one is you have the log base 7 of 5 times log base 7 of x, or square root of x. So I pretty much have log base 7 of 5 plus log base 7 of square root of x. Now remember, square root of x is x to the 1/2 power. So I could take that 1/2 power, that's a square root, I could put it in front of this log right here. So I actually have log base 7 of 5 plus 1/2 log base 7 of x. And that would be completely written out. All right, going on to the last few. Good. Video's almost done, which will be nice. And I'm going to check how long it's been real quick. So, number 23, all right, is log base 4 of 7 minus, oh, well, hold on, condense the log. Okay, so now this was expanding. We were expanding the logs here. This one, I'm going to be condensing them. Okay, so other direction now. So if I have log base 4 of 7 minus log base 4 of 10, I'm looking at this one. If I have log base 4 of 7 minus log base 4 of 10, I should realize that subtraction would be the equivalent as dividing the two. So log base 4 of 7 divided by 10. And that would be the final there. That would be condensed fully. Okay, next one, number 25, I'm looking at this one. So if I have 6 natural log, which is just log base e of x, and 4 natural log of y, I'm going to just leave it as natural logs this time. Remember, that is the same as moving the 6 up top right here. So I have natural log of x to the 6th plus natural log of y to the 4th. And if I'm adding the two exponents together, that's the same as multiplying. So I could do natural log of x to the 6th, y to the 4th, like that. All right, next one. Okay, so I have log base 5 of 4 plus 1/3 log base 5 of x. So I'm going to take that 1/3 and I'm going to put it up top first. So I end up with log base 5 of 4 plus log base 5 of x to the 1/3, or just cubed root of x, like that. And now because they're added, they're also equivalent to being multiplied. So log base 5 of 4 cubed root of x, like that. Okay, next one. So again, I'm going to begin by taking the numbers in front, realizing that they're multiplied. I can bring them up to the exponential area because I'm dealing with exponents. I'm working in exponents right now. So I have actually natural log of 2 to the 6, which is actually 64, minus natural log of y to the 4th. So, and I'm subtracting the two from each other. So I have natural log of 64 divided by, because it's subtracting, y to the 4th. Y to the 4th, like that. This is all in one thing, like that. Okay. Next one. I have a bunch of addition, which means I'm going to end up with a bunch of multiplication. So I have 5, so natural log of, here, natural log of 2, and then I'm taking the 5, putting it up here, to the 5th, times, take the 7, put it up here, natural log of x to the 7th. So I'm going to start skipping some steps. X to the 7th, 4 is going to come up here, times natural log of y to the 4th, y to the 4th. 2 to the 5th is 32. So I have natural log of 32, x to the 7th, y to the 4th. And that'll be the final answer on that one. So that's condensed. And then lastly, finally, log, oh, actually, no, that's it. So that would be an odd. So I am done with the video. If you guys have questions, you can feel free to come in early in the morning.